Imagine if the servo motors in this world disappeared in an instant. What kind of disaster would it cause? Patients who were preparing for physical examinations could not do so due to machine malfunctions. A car that was driving fine on the road suddenly broke down. The plane could no longer take off. What about the ships that had set sail? They could not dock either. All processing in the factory came to a halt. As a result, there was a shortage of supplies, the economy suffered, and the world fell into chaos. All of it, just because the servo motor is gone. So, the application range of servo motors is so extensive that it exceeds our imagination. They have become an indispensable part of our lives. It's precisely because people are so dependent on servo motors and with various requirements that there are many types of servo motors. What kinds of servo motors are there, and what are their differences? At present, the most widely used is the servo motor that can rotate a 180 dig, and the servo motor that can rotate 180 dig is popular. It's simple because it works, because in our actual applications, we usually operate from left to right, from top to bottom. It's like when we do a job, it's usually from left to right or from top to bottom. Very simple logic. Since we have already made a 180-degree rotating servo motor, it is natural to make one that can rotate 360 degrees. Therefore, another type of servo motor is this 360 degrees, continuous, capable of infinite rotation. However, this type of servo motor generally only allows it to turn left or right. It is less able to set specific positions for rotation like the 180-degree model. So if you have up and down, left and right, does it have to be a linear motion to be complete? The next one is the linear type of servo motor. This kind of control is less tiring, it just needs to move back and forth. Servo motor is also the difference between digital servo driver and analog driver. These two are actually not very different. The difference is that one is a digital signal and the other is an analog signal, which we can understand as the language they use, is the language between the servo and the transmitter and receiver. Let's assume that the digital signal is in Chinese and the analog signal is in a foreign language. If you speak to you directly in Chinese, you will understand immediately. But if it's in a foreign language, you might need to translate it. So it's a digital signal and it has a higher accuracy. Digital servo machines have much higher speeds and faster response, so to speak. They are better, so they are more expensive.